Hello, this is chapter 2.4, and we're going to continue our discussion on slopes. This whole thing is just to be looking at a couple practical examples of slopes and things that you can do. So this is more on slopes. Okay, the first thing we're going to look at is how to talk about what a parallel slope is and perpendicular slope. So we're going to be talking about parallel and perpendicular slope. Those are the symbols for them. Parallel slopes are two lines that don't cross, have parallel slopes. Okay. Perpendicular slopes are two lines that do cross, but they cross at a 90-degree angle. So, if we have a slope of 4, what is a parallel slope? Well, parallel slopes are just the same slope. Two lines are parallel if they have the same slope by definition. So a parallel slope would equal 4. All right, so two slopes are parallel if they're the same. Now, perpendicular slopes, the two slopes are perpendicular if when you multiply them together you get -1. So m1 times m perpendicular equals -1. That's one definition. Another one is that the two slopes are negative inverses of each other. So an example of that, again, if m1 equals 4, a perpendicular slope would be the negative inverse. It would be a -1/4. So m perpendicular equals -1/4. So another example, let's say you have a slope of -3/5. What is a parallel slope? Well, parallel slope is the same slope. So parallel is -3/5. What is the perpendicular? Well, the perpendicular slope is the opposite sign, so it's going to be positive, and it's going to be that fraction flipped over, so positive 5/3. Okay. So that's giving you a short introduction to parallel and perpendicular slopes. Now let's work out a common problem they're going to have. The first common problem they're going to do is they're going to give you an equation of a line and a point. So let's say they gave you 4x plus 7y equals 10. So there's equation of a line. And they're wanting you to find the point that goes through. So you have a point here. The point is, I don't know, 14 and 3. And they're saying, okay, we want to find an equation of the line that goes through this point that is perpendicular or parallel to this point. So let's do them both. Say they're asking for both. So they want the equation that's parallel. So find the equation that's parallel to this one that travels through the point. (14 and 3). Okay. So we'll go ahead and do that. We will first need to identify the slope. In order to identify the slope, you need to solve this equation here for y. We'll do that. So 7y equals -4x plus 10. Then divide both sides by 7. You get y equals -47x plus 10/7. And all we're really interested, once we've solved that, is the slope, is this right here, -4/7. Okay, we're going to take that slope and we're going to separate it out, put it over here. And now we're interested in finding the parallel slope. Well, what's parallel to -4/7? Well, that's the same slope. Two parallel slopes are the same. So our parallel slope is -4/7. And then we're going to use this slope and the equation that we looked at in the last video. And the equation is y equals y1 so m times x minus x1. We're going to use this parallel slope here and this point here and this equation here. So those are the three things we need. We need this, this, and this. We're going to use those together to find the equation of the line. So here is x1, y1. Here's our slope. There's our equation. So we plug it all in. We're going to have y minus 3 equals negative 4/7, that's your m, times x minus 14. Okay? Then what you're going to do is you're going to distribute. Negative 4/7 times negative 14 is positive 8. Then you're going to add 3 to both sides. And you end up with the equation of the line that travels through the point 14,3 and is parallel to the given equation up above. Okay, now you can do the same thing. Let's say they gave you the point, they said, I want a line that is perpendicular to this equation that travels through this point that is perpendicular to that equation. So this one's the same problem. We want a line that is perpendicular to this. It's perp to this, travels through this. We want that equation. Well, first thing is we need the equation, the slope. So rewrite this as that. What is the slope? The slope is negative 3. But here they're asking for perpendicular. What's perpendicular to negative 3? The perpendicular slope is a positive 1/3. So you're going to use that here. You're going to use that and the equation to solve it. So you're going to have y minus y1 equals m perpendicular times x minus x1. Here's x1, here's y1. Plug them in. Y minus 3 equals 1/3 x minus 3 in parentheses. When you work it out, you're going to end up with y minus 3 equals 1/3 x minus 1. Add 3 to both sides. And your final equation is y equals 1/3 x plus 2. So this is an equation of a line that is perpendicular to the original line but travels through the point 3,3. Okay? And we're done. So that's one problem we're going to be working on here. Okay? The next thing, the other thing in this chapter that's really important is we're going to be looking at slopes as rates of change. Like you can think of a slope as a rate of change. Okay, example would be, miles per hour, right? So how many miles do you go per hour? 1 hour. So slopes is another way of looking at a rate of change. The rate of change in this case is miles per time unit. But it could easily be, doesn't have to be time, it could be, like the pitch on a roof. Your rate of change is how fast does y change when you change x by the x coordinate by 1 or something. So let's just think of slope as a rate of change. Okay, that's the other thing in here. And the last thing is they are going to be talking about, last important thing here, is they're going to be looking at the average rate of change or average rate of change of a function at 2 points. So in here, they're saying given some function, so here is some function f of x equals x squared minus x plus 1. And then we have 2 points. We have maybe the point, 2 coordinates on the, not 2 points. I'm getting 2 points on the x, 2 x points, 2 x points, not paired points. So And let's say, so we want to find the average rate of change when you go from x equals 1 to maybe to x equals 5. So we have this function. We want to know what's the average rate of change of this function when you go from x equals 1 to x equals 5. Now this function is some kind of curve, and you're wanting to know what, if you go from here to here, what the average rate of change is, which would be the slope if you were to connect these two dots. Okay. Now there is a formula for that. Here it is. And this is just your slope equation. This is y2 minus y1 over x2 minus x1. But we're using function notation here. So what you're going to do is you're really interested in, if this is 0.2 and this is 0.1, what you're interested in is f of 5 minus f of 1 over 5 minus 1. Okay? That's what you're interested in. So 5 minus 1 is 4. This right down here is fairly easy. In this case it's 4. But what's f of 5 minus f of 1? Well, you have to plug them in. So f of 5 is 5 squared minus 5 plus 1. That's f of 5. And then we're subtracting from it 1 squared minus 1 plus 1. All right? So here is f of 5, and you're subtracting f of 1. F of 5 is 25 minus 5, which is 20 plus 1, so this is 21 minus 1. These cancel, minus 1 over 4. So 21 minus 1 is 20 over 4. And we have 5. So your average rate of change is 5. Okay, and that's how you're going to work these out in this case. Hope that helped explain it. See you in class.